Hello and welcome to today's web seminar entitled Moving Beyond Batch, Transactional Databases for Real-Time Data. I'm Peter Visciuso from VoltDB. I'll be moderating the webinar. Now I'd like to introduce our speakers. We're very excited to have with us today Mike Gualtieri, who's a Principal Analyst at Forrester Research. Mike's research focuses on software technology, platforms and practices that enable technology professionals to deliver prescient customer experiences and breakthrough operational efficiency. His key technology and platform coverage areas are big data strategy, Hadoop, advanced analytics, machine learning, data science practices, predictive app design, and emerging technologies that make software faster and smarter. And all of that makes him the perfect presenter for today's topic, and we're excited to do this with him, along with Dennis Duckworth, who's Director of Product Marketing at VoltDB. Dennis helps companies extract real business value from their fast data. That's his major role with VoltDB. He joined us not too long ago from IBM Netezza, so he's got a lot of experience in the data marketplace, and he holds a degree in electrical engineering from Stanford University. And with that, I'm going to turn it over to Mike Gualtieri to kick off the webinar. Mike?
Thank you, Peter, and hi, everyone. My name is Mike Gualtieri, Principal Analyst at Forrester, covering all things big data and advanced analytics. And, you know, whenever I talk about a topic like this, right, and we're talking about moving beyond batch, I like to set, what are the business priorities? So it's good to just get a reminder of that. And based upon our surveys in 2016, and 2015 and 2014 for that matter, customer experience has risen as the top priority, right? And along with that goes product innovation. And really what that means to businesses is they have to create new customer experiences and new business models. And those new customer experiences often involve treating customers like individuals. I sometimes call it like treating them like celebrities. And you have to learn individual customer characteristics and behaviors. You have to detect what they need and want in context, and that means in real time, and then create applications that will adapt to that individual customer, right? So sure, you can create one application, but that application has to have many, many variations, and it has to act in real time. Now, part of learning those individual customer characteristics and behaviors is analytics, right? So that has to also be done faster. It's often done in batch. We also see that there's quite a bit of enterprise interest in IoT. 82% of enterprises are interested. So this is more of a rising trend, but likewise, those enterprises also have to learn the individual device and systems of devices, the characteristics and behavior, detect that context in real time. And then further, when we survey companies about their analytics, faster time to value and advanced analytics is most important to the business. And that's in total alignment with these business priorities. You need faster time to value, faster analytics, because you need to understand these systems, these IoT devices, and the customers, and you have to do it. You have to use more advanced analytics to be more predictive, and that is why we talk about big data or data. And if you think about data, though, it's really like a drop of rain. It originates in an instant, and then it travels far before it ripples. So it originates in a cloud, and then it finally makes its way down, and it causes that ripple, and that ripple is the insight. So data and analytics is absolutely necessary, but it's necessary increasingly in real time. And all data originates in real time. It's a click. It's a transaction. It's clicks that lead to a transaction, but it originates right now. It originates in real time. The problem is enterprises, from the beginning of enterprises using computers, analytics is usually done much later. And that's a big problem, especially when we're trying to create these new individualized customer experiences. Now, at Forrester, we call those insights perishable. So the insights that you gain from the data are perishable. And what that means is that over time, if you can't decide and act on those insights within the given time frame, then it's too late. Those insights have perished. Now, perishable insights isn't all about real time, right? Because as you can see here, there's some insights that are strategic insights that you may act in weeks and months, like you may decide to expand a product line. That's not something you do in real time. So there's a full range of perishable insights. And if you look at this chart, most companies have focused on operational insights and performance insights, but less so on real-time insights. And where are those operational and performance insights done? Usually, those are the analytics that are done after the fact, but those too need to be done much quicker. So if you actually look at the process of data originating, and remember it all originates in an instant, those analytics are performed, insights are gleaned from those analytics, you make a decision, and you act or not act. Now the idea is that this process has to be compressed. Batch analytics just takes too long. I mean, even by the time you move the data to another platform and then you ETL it and you process it, that can take forever. I mean, even a day can be forever in today's world. So you have to compress those analytics operations to maximize the value of data. So you have to pull all those operations to the upper left as much as possible. Now, I've been throwing around the word real time. And a lot of companies will say, well, I don't have a real-time need. Well, real-time just means highly perishable. It means business time. So if a customer walks into a shopping mall and you have a shopping app that detects their presence, well, in that case, real-time may be a few seconds. You know, if a shopper clicks on an online ad and you have to respond to that in some way that's individualized, that could be in the milliseconds. So every business, your business, has some sort of something that's real-time. Right, so the idea is you need to be able to do analytics quickly so you can do applications. Again, treat this shopper like she's an individual. Not, is she buying this, should I send her an offer? Why send her a coupon for 10% when a gentle nudge will have her buy? Right, so it has to be individual, but it has to be done right now as things are added to the shopping cart. In the world of IoT, sensors in the wheel detect slippage in the car, and obviously can alert the driver or apply braking. But what if it could also, through telemetry, real-time telemetry, warn drivers down the road? And then finally, what if it can learn that this is a slippery curve? Right, so there's a full range of perishable insights there. What if a customer is transacting online? What if they're thinking about moving to a rival firm? What can you do about it? So there's real-time situations in every business, and this is a very, very small sampling. Now, if you think about creating the applications of the future that necessarily must infuse these analytics to respond in real time, you need a couple of capabilities. All the data that's coming in, remember the data that's born in an instant, let's just call that streaming data as indicated here, that creates your real-time context. You have to have that. You have to know what's happening right now because the application has to act, recommend, decide based upon what's happening now. You have machine learning that occurs to add learned logic to that application. So see, you start with the program logic. That's your business rules. But as you have more and more real-time context in machine learning, you can now add learned logic. Now, getting to the data scientists who actually do these analytics, whether it's predictive models or just plain old analytics, a recent survey, 91% of these data scientists has expressed an interest and in some cases are using real-time data for modeling. So real-time isn't just sort of a fantasy, and it's not just about application development. Even the data scientists want to move on from batch processing to more real-time type processing. So real-time analytics is necessary. It's absolutely necessary to detect, to create that context, and act in real time on those perishable insights. The challenges to this is that we are in a business intelligence, analytics, batch world. Everything is oriented towards batch. And you can understand why it happened. That's how things happened. You had a transactional system. It fed some sort of analytic system, and then batch analytics was done. So in the 60s, the 70s, the 80s, and even the 90s, no big deal, right? But now, more connected consumers, mobile devices, IoT, it has to be done now. And the question is, why? Why are we waiting to do this analytics? Why are we doing it in a batch? And to understand that, you have to understand how technologies change. I'll get into that in a second. So these are some of the top technology challenges. You can see here, data volumes too large is a challenge. Time it takes to assemble that data and move the data, difficult integrating it. So, what is the solution? Well, here is what many think the solution is, which is to create a data lake. But how does the data lake actually solve any of these challenges that I just listed? The answer is it really doesn't, right? Because it still involves moving, it still involves integrating. So what we think the solution is to step back and think about what's really needed to do that analytics. And there's really two concepts I want to leave you with. One is data gravity. Now, the data gravity approach says I am going to perform analytics where the preponderance of the data originates. So you see what I'm getting at here? Where does the preponderance of data originate? And where's the most valuable preponderance of the data originate? It originates in a transactional database. It's all about transactions, right? Because that is that most valuable connection with the customer. So you've got the preponderance of the data, so why not do analytics where it originates in the transactional? And I'll have some answers to why not. There's some databases that aren't optimized for that, but there's new technology that is. Now, the second question to ask is, okay, it's not just about where the data is, but there's also the notion of compute gravity. And compute gravity says I am going to perform analytics where the preponderance of the compute resides, right? So you can see how these are sort of competing forces, if you will, but they don't have to be, right? So what if you had a distributed and powerful compute capability in the same place that you had the preponderance of your data? Well, there you go. That's where you can perform the analytics. So if we look at doing that in a transactional database, the data scientists are cool with that, because you can see here that data scientists recognize the importance of transactional data in predicting data models. Look at what 1 and 2 are. Customer reference data, which is usually in the transactional database, and the transactional data. So why are we moving all of this data to a data lake to do analytics when we already have it together? We have the preponderance of this data already together. Well, the reason for that is that a lot of traditional transactional databases are designed for write. They're designed for writing data, but they're not designed for read. And read is what happens with analytics. Dennis Duckworth from VoltDB will talk later about how that technology and analytics can be done in the transactional database. Now, one of the things you also need and is essential to fast analytics if you're doing a transactional is in memory. Right, and we know that in-memory access is roughly 58,000 times faster than disk. So that's huge right there. We know that the chip costs are going down. So another way to capture those perishable insights in real time is to do it. Don't move the data, because that takes time and complexity, but also do it in memory. So the capabilities that you're looking for in this type of a transactional engine to actually do analytics is scalability, right? Certainly transactional databases have to be able to scale writes, transactions. But if they're also going to do analytics, they have to scale workloads. They have to have that ingestion, because remember, that's streaming that real-time data. They have to have an analytical throughput capacity. They have to have low analytical latency, and of course it has to be mission critical. And they also have to be able to take in other spurious events, right? So you've got transactions, but you may also have GPS locations, think of it more as IoT. And then you have to have some analytical operators. You actually have to have a rich set of analytical operators to actually be able to do the analytics in that engine. So ability to ingest all data sources, so structured and unstructured from multiple sources in real time, handle any volume and scale. That probably goes without saying in an analytical engine. Process and analyze that data in real time, because remember, it's all about these perishable insights, and it's transactional. And analytics in these new modern applications don't become a report on someone's desk. They actually become essential in the application, which means the platform itself has to be fault tolerant. And think of analytics not as sleepy dashboards or reports, but it's an application development. So you need tools that you can easily to manage and monitor and expand that platform. And you also want visualization tools, so you can visualize that data in real time to get new hypotheses. So when we think about batch, is batch necessary anymore these days? Well, yes. I mean, it's not sort of a binary world where one thing takes over the other, but is there a preponderance of analytical workloads that now have to be done in real time? The answer is yes. So there's a big opportunity for companies to rethink where and how they do their analytics in real time. So look at the insights that you need in your organization and consider real-time and operational insights where you're going to do those. You need to do those where the preponderance of the data and the preponderance of the compute is. That's the right transactional database. For certain performance insights, reports, and longer-term strategic insights, batch analytics is fine. So use real-time analytics, run it based upon data gravity and compute gravity. You'll be able to create a whole new class of real-time customer experiences. So thanks for your attention. I hope you find that useful. I am now going to turn this over to Dennis Duckworth from VoltDB. Dennis?
All right. Thank you very much, Mike. And there were some great points that Mike made in there, and that's one of the reasons we love working with Mike. He sees things from our perspective as well as obviously from Forrester's perspective. They line up very nicely. Some of the key points from Mike's presentation for me were customer experience and product innovation are top priorities for businesses, and real-time personalization is an example of one of the key enablers for better customer experiences. IoT is driving a lot of interest, and if you think about IoT, there's lots of data coming at you quickly, and you need to decide what to do with that data or on that data based on the latest data that's coming at you, as well as the context of historical data. Fast means different things to different companies. Many companies want faster time to value, but also want faster performance. They want better agility out of their systems. And it was really interesting to see that analytics done too late can have worse than zero business value for a customer. It can actually have negative value if the insight or action is based on outdated data. As Peter mentioned, I came from VoltDB from the data warehousing space. And if you look back at data warehouses, they arose from the need that businesses had to give access to their transactional data to business analysts. And that was to report on it. So that was the birth of descriptive analytics or traditional business intelligence, if you will. And as Mike said, data gravity and compute gravity would tell you that the sensible thing to do would be to do the analytics in the transactional system. But companies run their businesses on those transactional systems. And IT certainly doesn't want just anyone accessing those business systems, those transactional systems, because they might slow them down or even crash them, and there goes your bookkeeping, there go your sales orders, and so forth. So that was sort of the beginning of the separation of transactional and analytic systems. But with newer technologies like VoltDB, we allow those to be joined back together, and we're going to take a sort of long path to get there. So big data is a category that is often used to subsume analytics. And so we could go back and take a look at how this came about and why analytics became a key driver for big data. The idea is kind of illustrated on this chart, and it's a variation of one of the charts that Mike showed, but one that we like to use here at Volt. The analytics has gotten to be quite complex with things like clustering algorithms, machine learning, and so forth. But what this curve here now shows, well, anyway, there's a nice little chart that shows the value of data as it's assembled. And the idea here is that a single bit of data doesn't have much value, but when you take it together with a bunch of other data, it gets to be really interesting. So single bytes, not very important, but you gather up your gigabytes or terabytes or even petabytes of data, and you can start to see really interesting patterns emerging from that. It may take some time, as Mike alluded to, days, even weeks or months, but that's what all these data scientists are doing with their days. They're looking deep into those gobs of data. So I like to look at the accumulation of data and how it contributes to business value by using this model of the data, information, knowledge, wisdom pyramid, if you will. And some people would argue that this is really a very too simplistic of a view of things. There are people like David Weinberger of Harvard University says that knowledge is much more complicated. There are a lot of different inputs to it. So instead of trying to work to a complex graph like this, we'll just go back to the pyramid and use that. So we have data at the bottom, and this is where all our little bits of data are being produced. And at some point, sort of to the water metaphor, or data is the new oil, data is the new natural resource, there's a certain refining or processing that goes on that data to produce information. So there's some type of gathering of that data that will allow you to have concrete bits of information that are available to you. And then that information is further defined or refined and processed to produce knowledge. And finally, the end goal is to have some wisdom out of that. And that's where you get your real business value, and that's what we're calling insights from our data. And now you can take that model and map it to a business use case, for example. So the one we're going to use here is that of a gaming company, so online mobile gaming, for example, trying to determine next best action, which is a common analytics type of term. And apologize for the arrows getting a little skewed there. But we start at the bottom with the data. So we have data about a user. User is playing this game. The user is at the cave challenge. The user is at the cave challenge. The user is at the cave challenge. So those are our little bits of data. We can start distilling that down into some information, and that information might be that, well, this user is at this challenge for over 10 minutes. And if we look at historical data, that's more time than most users spend at that challenge. And if we look further into that data and into that information, we have some knowledge that was able to be distilled from that historical data that tells us players who spend that much time at that level or at that challenge, they quit out of frustration. When users quit, that's not a good thing. We're looking to keep our users engaged, and we want to try to keep them moving in the game to allow some monetization opportunities later on. So maybe some wisdom that we've gained from that experience or that knowledge is if we offer the user a free magic sword to get through that challenge, they'll keep on playing, and they're likely to spend real money later on to buy a shield to go with that sword. So there's a way that data, the individual little bits of data that aren't necessarily useful, like the user being at this particular challenge, ends up contributing some business value. And so we at VoltDB kind of take that approach and look at what this provides to us. So that wisdom really becomes an insight. And the goal of analytics in this particular case is to produce actionable insights. And that's all well and good. And as Peter mentioned, I spent a lot of time in the data warehousing space, and that was sort of the holy grail for us to get customers to see the value of producing actionable insights, to be able to do analytics at every step of the way. Well, there was a problem with that. And the problem tended to be that many companies stopped at that point. And it could be the fact that they were looking at this as a big data problem, and big data tends to be big and cumbersome and slow. And so they would be able to produce these actionable insights, but very few of them actually then implemented a mechanism for taking those actions. Maybe they would make a change in their sales organization, another slow process, but they weren't able to react to data immediately and to extract the maximum amount of data of business value from that. So VoltDB kind of looks at it a little bit different and says that the analytics really is not necessarily a big data problem, but a fast data problem. And if we take a look at that chart we had before of the value of data as it grows, that remains the same. We continue to have the value of data growing and becoming more valuable in combination with other data. But we can also add another axis to this, and this is going to be the fast data axis. So in addition to the value of data growing in aggregate, there's also what Mike was talking about before of the perishable value of data. And this is of an individual bit of data. So what we're saying here is that you can take action on your data immediately as it produced and get tremendous value out of it, tremendous business value. Now the key here is that you're learning, you're gaining all that wisdom from, sorry, my builds are having a little bit of an issue, but the value of the wisdom you're getting is going to be applied to that data coming in. So you're going to be dealing with that real-time data coming in the context of the historical data, in the context of the wisdom that you got from that business data. And if you look at the systems that are out there today, in the big data space, we have Hadoop and the data warehouses, and the NoSQL guys are kind of skirting the issue there. In the fast data space, you have some primitive types of big fast data solutions like CEP or complex event processing, or combined with databases sometimes to maintain value. But the value that VoltDB provides is in the high end of that space there, providing value on that data as it arrives in the historical context of the wisdom that you've gained from the big data. Okay. So what does VoltDB do really well? Looking at our use cases, looking at how our customers use us, we're able to ingest data or events. Really, those are really the same things as Mike was talking about, those key clicks, the user actions, and so forth. We can ingest those really quickly. We're talking about hundreds of thousands to millions of events per second. And more importantly, VoltDB allows you to take action on that data and those events in context really quickly. Under 10 millisecond response times are very typical, and sometimes less than 1 millisecond for some of our customers as well. And that is something that a lot of vendors are touting out there now, especially the NoSQL guys. But what VoltDB does that is it allows that speed and that throughput with immediately consistent data and accurate data with strong isolation that is strongly serializable and high durability, which are guarantees that not many, if any, other vendors make out there. We also allow that data to be exported very quickly to downline systems so that you can use it to fill your data lake or your data reservoir or your data warehouse. And it allows you to create what we call a fast data pipeline. And all of this in a highly scalable manner, being able to support millions of users, being able to scale out easily on commodity servers. And also what we have found in replacing some other products is that we scale much more efficiently than many other systems. Whereas you might need 100 MySQL servers, you might only need 7 VoltDB servers to do the same job and actually to do a better job at it. And don't believe just what we say, and this is an important point, that there are a lot of marketing claims that are out there, especially around speeds and feeds and throughputs and scalability and so forth. We actually took the test. We took our product to Kyle Kingsbury of Jebsen and had him do his very rigorous break test on VoltDB to make sure that we do what we say we do. And based on our claim of strongly serializable, This was the strongest Jepson test that was ever run, and our latest version 6.0, actually passed that test. And there's a link on 6.4 passed that test, and there's a link on the bottom of that page in case you want to go read about the blog and to access Kyle's report on that test. So for us, the magic in doing analytics in real time is really being able to take actions in real time. It's great to be able to have actionable insights, to take all that big data and to distill that into business value and to drive insights. But it's really about what you do with those insights that allows you to benefit the most, and that's where the actions come into play and allow you to act on that business data. Some of the time-sensitive or real-time use cases that we've seen from our customers in the telco mobile space, category of authorization. So someone's hitting a button on their phone, they want to access a certain application, they want to connect to the internet. Do you allow them to connect? That's a very cost-sensitive issue for carriers. If they connect a person who doesn't have any money left, well, basically they're going to be paying the bill. Or likewise, if they deny a connection for someone who does have money in their account, then they are risking losing a customer. In the gaming space, I talked about a gaming use case before with personalization, where you have a user who's getting stuck at a particular place in the game. You want to keep them engaged, and kind of the dirty secret of online gaming is everyone is playing a different game. It's not the same game that everyone's playing. The gaming companies are changing the behaviors of the game to try to keep you engaged, to try to help improve their ability to monetize those game actions that you're doing. So they want to try to highly personalize that, and that's done in real time. You can't take weeks to figure out that you need to offer someone a sword. It has to be within milliseconds or seconds if you're lucky. In the financial services case, customers, we have a case where there's a certain amount of arbitrage going on. So, for example, in the morning they figure they have a ton of IBM stock that they need to offload, but at the same time they have clients who are interested in buying IBM. So how do they maximize their profit on their holding of IBM, selling some while not upsetting the market, also being able to fill those buy orders for their clients? All of that being done in real time because we're dealing with real money here, and transactions are critically important to make sure they're not double selling a certain amount of stock. In ad tech, billing management, these billing ad tech companies are bidding on spaces on websites for a client's ad, and sometimes those clients run very low on their budget. And one of the quandaries that some of these companies get into is, should they place that last ad? The customer is down to their last few pennies of ad placing budget, and if these companies are using eventually consistent systems, they may not know to the penny how much money that customer has left in their billing account, how many ads have been placed for them. So you can use a highly consistent system like VoltDB to be able to count those pennies to the last penny to know when you should or should not place that last ad. And across verticals, we see a common use case of service level agreement management. So this is a critical one, not only in the financial services space, but the telco space and many others that we've been seeing, where you have complex multi-step processes, but short fixed times in order to, within which to complete those processes. And you have to take a look and see how each one of those steps is proceeding to know whether you'll be able to meet your overall SLA or not. And you may actually have to accelerate a certain step or to dedicate more resources, compute resources or something, to be able to have those critical steps be able to meet their sub-SLAs. And what's in it for the company? Well, if they don't meet their SLAs, they're paying some type of penalty, whether they're allowing their customer to place free ads in the ad tech space, or whether they have to buy back some stock based on a client's purchases. So SLA management is becoming a critical factor that really benefits from the characteristics of VoltDB. So for us, it's all about the business value. The batch analytics that were performed on data lakes provide these actionable insights, this wisdom that you can then take. But it's really then about taking those actions, having a system that allows you to make best use of that wisdom by reacting to real-time data coming in and being able to highly personalize ads, or make the best stock purchases for your company, or to be able to manage your SLAs effectively. And that's where it becomes critical to take the real-time analytics and to derive that business value. So in conclusion, just some key takeaways I hope you get from this webinar. Companies want to improve the experience that their customers are having and looking to use more analytics and to do those analytics faster as one way of doing that. There's a need for processing high volumes of data coming at you in high velocity. You want to be able to extract those actionable insights from that, so get to the wisdom phase, be able to figure out what you should be doing based on all that historical data. And then most importantly, you need to be able to act on those insights based on the real-time data stream that's coming in, be able to react to customers, being able to react to market changing conditions, and so forth. And fast data solutions like VoltDB allow you to process that data quickly, to extract those insights very quickly, and to act on them very quickly, all in real time to maximize the business value of that data. And with that, I'll turn it back to Peter.
Great. Thank you, Dennis. And before we get to questions, and if you have a question, you haven't entered it, please type it into the Q&A window. We just ask you to answer 2 simple polling questions. Just give us feedback on this webinar. How helpful was it? Very, somewhat, not very. Take a second, please, and click on your response. Okay. And then lastly, what other topics are you interested in learning about? Did you learn about what you hope to learn on this webinar? And if you have other topics you're interested in, we'd be keenly interested in understanding those. Just give people a minute to fill that out. Okay. And Mike, I hope you're still there. I've got a question for you.
Hi, Peter. I am here.
Excellent. We've talked a lot about analytics. As you well know, analytics is a really, really broad term. Can you talk about the difference in the type of analytics that are being done on, real-time streaming, fast data versus data at rest?
Sure. Yeah, there's a few types of analytics in broad buckets, right? The one that probably most people are familiar with is often termed descriptive analytics. And this is where you're looking at data, you're totaling up data. Think of it as a report, so you're reporting on what's happened. There's also predictive analytics, which is analyzing data to find a predictive model. So a lot of times you use statistics and machine learning to do that. And then streaming analytics, or also known as real-time analytics, this is when you're actually doing the analytics as the information gets created. So rather than getting the information, copying it, and then analyzing it, doing descriptive, you're analyzing it right now, so you can take action on it. So some people also talk about prescriptive analytics, and prescriptive analytics is analytics about decision, how to make an automated decision and take an action that's more effective. Generally, people think of descriptive analytics as batch, but it doesn't have to be. And I think that's part of what we're saying here is that, and I actually have a hypothesis talking to companies and covering this, that there's an enormous, I believe, there's an enormous amount of time and money wasted on traditional business intelligence. And they're just like creating reports that either no one looks at, or that the information is too old to act on, or it's not in a form that's actionable. So, my suggestion is that why not create an architecture and a platform to do all analytics in the stream, so real time. Hope that helps.
Yeah, that was helpful, Mike. I'll add a few comments there. When people hear analytics, going back to my data warehousing days, it does mean different things to different folks. And for people who have petabytes of data, being able to do things like clustering and k-means and so forth on those petabytes of data, finding patterns in that data, it starts with what Mike called as descriptive and gets into the predictive of saying not only what happened, but what will likely happen based on this pattern, and then prescriptive of what's our best course of action based on that. But for the fast data space, what that translates into really is what I like to call decisioning. So it's taking advantage of that knowledge that you've gained and the wisdom that you've gained from those huge honking data warehouses or data lakes, those big patterns you've seen over months, if not years of data, and being able to see that pattern in the incoming real-time data stream and making a decision based on it. So you're not just reacting to a real-time pattern, you're reacting to a real-time pattern of data in context of its historical data. And that, for us, is the key to the analytics in the real-time space, in the fast data streaming space. Being able to understand the current context of time of data in the historical context that you have already worked on.
Great. Thank you, guys. And maybe you can both comment on this question. Mike, you were talking about using a transactional database, in these types of applications. And the question is, how does a transactional database or VoltDB differ from a lot of the streaming solutions that are out there today that people are using on real-time data?
I'll take a first shot at that. So streaming is an interesting recent development. You have companies like Confluent coming out with Kafka, which is, if you look at it, it's really harken back to the enterprise service bus days of messaging. You want a central place where events can be stored and lots of different client applications can tap into it to know what's going on. And Jay Krebs has some interesting views of transactional systems and streams, saying a stream is a transaction, can be looked at as a transactional system. What we look at, we see that stream as being a very good addition for a lot of companies as that central repository for events coming in. But it doesn't necessarily give you the ability to maintain state. And so we see a lot of people taking Kafka and building these stacks, like you have the SMAC stack with Spark and Mesos and Akka and Cassandra, all trying to build the ability that we have in VoltDB in a single product. So not only can we take that stream of data coming in, and we work very well with Kafka if you happen to have that, but some of our customers have actually found that the latency involved in Kafka is too much to allow them to meet their SLAs. So they take the data directly into VoltDB, do their decisioning on it, and then feed it off to Kafka for all those downline systems. But so you have these customers or companies who are trying to build these solutions out of these stacks, and while the individual components of those stacks can work fine, it's the glue code in between all those components that really kills those companies and turns them from banks or from gaming companies into DevOps companies. They really have to become software developers and maintainers in order to get that stuff to work. So that tends to be the area where transactional systems can really benefit over just a pure streaming solution.
Yeah, Mike, I don't know if you have anything you want to add to Dennis's point of view there, your own perspective on it.
Yeah, no, I think I'm in agreement there. The one thing I would say is that data often does have to move, right? An enterprise has a portfolio of, literally dozens and hundreds of applications. And some of those applications are downstream applications that need that data. So something like Kafka, which is really a message queuing system, it can be necessary infrastructure for that type of thing. But for the most real-time of insights, I just remind people of that idea of compute gravity and of data gravity, and of doing that analytics, especially the real-time analytics where the preponderance of the data originates, because there's no latency if you do the analytics where the data originates.
Yep, great. And then just maybe a last question here, going back to the title. Started off talking about using batch and batch maybe not being the right approach. Mike, from your perspective, the developers, the organizations that are going to build these real-time apps, it's kind of a different skill set, mindset that needs to be applied, would you say? And have you seen that in organizations, kind of in your engagements with customers, where adopting a kind of a real-time per event paradigm is a big shift for companies, and how do they manage around that?
Yeah, when we do surveys, we definitely see companies thinking more in streams. but it's still below 40%. You know, so when we just it's a general question that we ask about that. So I think there's some more thoughts on this, but the overwhelming view on analytics right now is the view that we need to create a data lake. And I think that, you know, because we need to get all that data together for analytics, but I think that thinking should shift. And I think that the question should be, let's categorize the perishability of our insights. And once we know what insights we need and the perishability, then we can decide where we need that data and where we need those analytics to be performed. And I guarantee if any company does this, they're going to have cases where, yes, this makes sense batch in a data lake, but there's going to have a lot of use cases that they hadn't thought of that belong in a transactional system or more of a real-time system. So I think we're going to see sort of a swing back where companies are going to build a data lake and then they're going to be like, oh no, I have all these real-time insights that I need, these analytics I need in my applications, and now the latency is too long. So they're going to sort of swing back and ultimately find that balance. You know, data lake is sort of the preponderant thinking on this, but people are wising up to streaming architectures as well.
Yeah, I'd agree with Mike. The data lakes have become very popular recently, especially since people have seen the limitations of their data warehouses being, you know, primarily structured data, the need to be able to work with unstructured data. And it's just like any tool out there, when there's a new paradigm, it takes a while for people to adopt to it. And we see that talking with VoltDB customers and prospects, and it really depends on where they're coming from. So we have the traditional transactional database guys like the Oracles and Microsofts and so forth, who, when they're moving to an in-memory distributed database, they have some things to relearn to be able to take advantage of the high performance gains that are possible. For NoSQL guys who are used to spinning their own Java code or Python code or whatever else, we give them back the ability to use SQL and to be able to use things like transactionality and consistency and full ACID, which they thought they had to give up in order to get the high performance and the high speed. So it actually gives them the ability to go back to something that they might be more comfortable with. And the streaming guys too, anyone who's approaching it from the streaming perspective, being able to give them state or something as simple as being able to have guaranteed only once performance and characteristics out of their database because of the transactionality is something that can be a great benefit to them and something they can take advantage of by simplifying their applications. Many of the things that VoltDB does, our prospects and customers sometimes try to do first by themselves in their applications, and it makes the applications very rigid and very non-agile. So when you're able to trust the platform to do some of those things, and we work with our customers all the time to help them to get through those and to understand the differences that VoltDB provides and how they can take advantage of them. And usually they're very pleased with the results after that.
Great. All right. Well, we're going to wrap it up then. I want to thank all of our webinar attendees. As I said earlier, everybody who's registered will get a follow-up email with a link to the webinar. Please check out those resources. And I want to thank Mike Gualtieri. Mike, thanks so much for joining us. And
thanks, Peter.
Dennis Duckworth. It's a great presentation, guys. And we'll say goodbye. So long, everybody.